Hey guys, so today we'll be solving this problem called construct string with repeat limits. In this problem, we have a string and we have a repeat limit, which is basically telling us how many times a character can appear without being an adjacent and more than the repeat limit times in a row, such that we have a string which is lexicographically the largest. So by that I mean, let's understand with an example where we have CC, ZA, ZCC, and the repeat limit is being set to 3. The idea is that we'll be having a character such that we'll be arranging this character such that we do not have any characters adjacent to each other more than repeat limit times. So just a thought, we can actually try to sort it. Let's see how a sorted string would look like. For this is Z, Z, C, 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 and A. That's how a sorted string would look like. But there's a problem here that we want characters in not more than the repeat limit of times adjacent to each other. So if you see here that C, 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 these are 4 characters which are same and are like adjacent to each other, and we have the repeat limit set to 3. So actually, even though this is the largest lexicographically ordered string, we would need to go a bit lower than this by making it C, 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 A, C. So what I did was I moved the C to a different position and I put an A such that these characters do not occur more than the repeat limit times. So this is the final string that we need to return, and it's lexicographically the largest. So let's try to understand the approach. So what we can do here is actually maintain a map of frequency. So we can have something like CC ZAZCC. That's the string, right? So we can have a frequency map table where we have C occurring 4 times, A occurring 1 time, Z occurring 2 times, right? So once we have this, we also want to know that all these characters are actually in lexicographically the largest, right? So we would use something like a max heap to keep the values in a lexicographically largest order. So I'll just use this map to store all the characters inside it. So lexicographically, Z would be the largest, and then it would be C, and then it would be A. That's how we'll be actually maintaining this map of frequency table, right? And once that's done, we will go to the next step, which is we'll actually try to remove this and construct a result string. So result string can be constructed by, so let's see, let's pop this element out. So once we have Z, and I can check in the frequency table, Z occurs 2 times. So I'll put this and append this Z 2 times in my result string. So now that's gone. So once that's gone, we have C in it and C. So C is occurring 4 times, and we'll pop this out and we'll have C, C. And the idea here is, the problem with this one is that we have a repeat limit as well, right? That's what we discussed earlier. And the repeat limit is 3 right now, which is smaller than the frequency. So in this case, I'll actually be considering to find the minimum between the repeat limit and the frequency. So whenever we are popping out an element, we'll check the minimum between the frequency and the repeat limit. So the minimum between both of these is 3. So I'll just append it 3 times. Now this frequency, I'll need to update it to 1 because that's what is left between these. And actually, once we've used the Z1 as well, we'll make it to 0 because that's what we've used 2 times. We already used, and this is 3 times. So that's the frequency table situation right now. So C is actually popped out, but we need to do one more thing, is that because we want to use, so frequency of C is still 1, and we would want to use the C later on. So the idea would be to push the C again in the max heap. So how would you do this? This is an edge case that we'll be considering, is that whenever once we have actually popped out a max heap element and there is still the frequency of that character is still left in the map of frequency table, we'll actually get the character and push it back in the max heap, and actually in this next position we'll put another character inside it. So I'll show you with an example. So yeah, right now we have actually appended C 3 times. The next step would be that we'll check, is the frequency of the current character, which is C, is it greater than 1? Yes. Greater than 0 basically. Yes, it is. Then what we'll do is we'll actually pop this out. We'll pop this out and append this in the result string, and yeah, obviously decrease the frequency from here. And then once that's done, we will check that we'll actually push the C frequency inside it. So we'll push the C character inside it because the frequency of C is still left. So now we have this string, right? Now we come back again. We have still 1 element left. So we'll pop this out we'll append it C, like basically the minimum between 3 and 1 is 1, so we'll have one character appended here, and that's how we'll actually create the string. So this will be more clear in terms of code. Let's get to the coding part. Let's first maintain an unordered map. Is int and frequency table. In this map, we'll actually store all the characters from the frequency. We'll have frequency of ch plus plus, and we'll maintain a priority queue. And from this priority queue, we'll have all the characters from the frequency table. So frequency will all the characters in it. Once that's done, we'll maintain a result string to actually store all the results from the characters that from the logic that we'll be running through. So that will be the final answer. Let's run through the priority queue. Queue.empty. What we'll do is we'll get the top value, which is lexicographically the sorted and the first and the largest value. So val will be pq.top. So once that's done, we'll go to the next step, which is actually finding out the minimum between the frequency of that character and the repeat limit. So use will be minimum between the frequency of val and the repeat limit. Right? So now we need to know if a character like C is 4 times and repeat limit is 3, so we need to use the lowest value, which is 3. So once that's done, we'll go to the next step, which is actually appending in the result. So result.append, we want to have it min-use times, and we want the character as well. So once that's done, we'll reduce the frequency of that character from the frequency table. Okay, so this is a basic case where we are actually having a character in the frequency table. We are getting the frequency of that and appending in the result, which is the final string, and just adding that to the final string and reducing the frequency from the table. Now, in the case where we still have in the case where we have the character less than the repeat limit, it's fine because the frequency will be 0. But in the case where the frequency is not 0, we'll have to check for that edge case. So in the case of C will be added 3 times, but there will still be one character left in it. So frequency of val will be, it's greater than 0, and max heap and pq empty still false. Then we'll go to the next step, which is we'll get the next character in the priority queue. So next character in the priority queue is pq.top, pq.com. Okay. So once that's done, we'll reduce by 1 the frequency and also add it to the result. Okay. So once this is done, we'll also need to check here if this is not being 0. So if this is not being 0, we need to add it to the priority queue again. So push next. And anyways, once we are added the next character, we'll also need to push the current character because the frequency of the current character is still greater than 0. So we'll add the value. So once this is done, this will go on again and again until the time we get the lexicographically the largest value and the result. So let's run this. Yeah, so that's done. Cool. That's all. I think this should work. Yeah, let's submit it. All right. I hope you like this video. Thank you.